So this is like the perfect simulation of what the AP notes are going to be like, because in the beginning, hopefully you're like, oh, I know this stuff. This is Algebra 2 content, right? And maybe you just need a refresher. And then you'll see when we get to the end that the style of question changes a little bit. The AP will have some really straightforward questions, like literally describe the transformations, and then they'll always have a twist on it. Good morning, Mr. Sutton. All right, so again, 1-4, and this is the last section that will be on your test. So your test is going to cover C1 to 1-4. So we start with our common parent functions. These are things that are like recalls. So we have to know when we see an absolute value, it is a V. If it has no transformations, then there's a point at 0, 0. And we'd go up 1 and to the right 1 in both directions. And if it's absolute value, you'd go right 2, up 2, right 3, up 3, like a perfect little line there, as though it had a slope of 1. If it's a square root function, then it also has a point at 0, 0, and it looks like an arc that points to the right. It's half a parabola turned on its side is the actual shape, okay? And then again, we're going to like shift these around, move them around. The quadratic function or the x squared function is your parabola with a coordinate point at 0, 0. And then you would go up 1 and out 1 unless it has stretch or shrink. But then it grows exponentially, which is why the curve happens. So like obviously if I go over to 2, it goes up to 4 because you're squaring it. And then the cubic function, and this, it's hard because I can't make this happen on PowerPoint, but it does cross through 0, 0. And then this one is like the right side of your parabola, and this goes down underneath, so it doesn't actually cross over like this, okay? It goes down underneath as though you took the left side of the parabola and flipped it upside down. That's what makes your parent cubic function. And if you think about why that happens, if I have negative values and I plug them in and I'm cubing them, they will stay negative, so that's why the left side will point down. Okay, then comes the less common but still could happen cube root function and reciprocal function. So the cube root function has the regular square root on the right-hand side, but then it is reflected over the origin towards the left. I'll go back to domain and range on the bottom in a second. Go to the right-hand side, and this is your reciprocal function. Your reciprocal function, which is 1 over x, has an asymptote running through your y-axis and a horizontal asymptote running through your x-axis. And then the curves of my parent function go top right, bottom left. So all of these are things you have to literally know what they look like before we even get to graphing them, because it will say, take this graph, shift it in this direction, or here's an equation, describe the transformations, and we're going to move them all around. You want to understand the parent functions. You should also be able to, at this point, identify, okay, on the left-hand side underneath, you should be able to do domain, range, increasing, and decreasing. You can even be able to determine if it's even, odd, or neither on all of these. We won't go through all of them, but I want you to think about it. On the left-hand side, your arrows point left and right, which means your domain is negative infinity to positive infinity. There's no restriction on a cube root because you can cube root an odd number. A range would be negative infinity to positive infinity because those arrows are also going to point down and up. And then that entire time it is increasing. So it would be increasing from negative infinity to positive infinity. And this has origin symmetry, so this would also be an odd function. What's happening in the top right can be folded down and over to overlap with the bottom left. On the right-hand side, this time my domain stops and starts because of the asymptote. So it would go from negative infinity to 0. It can't touch 0, so it has a parentheses on the 0. It would start again at 0 and go to positive infinity. And the range the same. There's a break in my range because of the horizontal asymptote, negative infinity to 0 and 0 to positive infinity. And it is first decreasing on the left-hand side. This whole part would be decreasing, so from negative infinity to 0. And it stops, but it is also decreasing on the right-hand side from 0 to positive infinity. And it is symmetric to the origin, so it's also odd. All right, now we're going to start to move these suckers around. So the first kind of shift is a vertical shift. A vertical shift happens if we add or subtract something after the function. So outside the absolute value, outside the square root, outside this, if it's in parentheses and squared, outside the parentheses, if it's in parentheses and cubed, outside. If this was my cubic function, it would be like this. And if it was my reciprocal function, it would be like that. So separate from your function. And the same over here on the left, it would be a minus. And the same over here, it would be a minus. For me, these make sense. Like if I take a function and I add something to it, it should shift all my values up. If I subtract something from it, it shifts it down. So the vertical shift makes sense like naturally with what your brain thinks. Add, it's gonna shift it up. Subtract, it's gonna shift it down. All right, so example 1 says to graph each function. Now these really don't have to be exact other than the vertex and like 1 or 2 points on the squareds. But we know first that our parent function is what? It's a parabola. If it asks for the parent function, then it wants f of x equals x squared. So it wants the equation of the parent function. Technically, these are usually g's. Not that it really matters, but they're really g's. And f of x is usually considered to be the parent function, okay? The parent function is x squared. The shape of the parent function is a parabola. And then if it's plus 1, that means I literally shifted up 1. I would go up and out 1 on either side, and I would draw my parabola. And then with B, what's happening? Shifting down 2. So I'm going to take my parabola, I'm going to shift it down 2 places and draw the parabola. As we're doing these things, think about, we won't do it every time, but think about it. Could you do domain, range, increasing, decreasing, even, and odd? If I just did it with the first one, what's your domain? Good. No restriction on a parabola, right? What's the range? 1 to positive infinity. That 1 gets a bracket. Is it, well, it's doing both. So let's say, where is it increasing? From 0 to infinity. Where is it decreasing? Good. And is it even, odd, or neither? Even, because it's symmetric to my y-axis. Yeah.
For even, odd, so even is if it's symmetric to x and y?
Just to the y-axis. So if you plugged in a negative, so from looking at it to the y-axis, from your equation, if you plug in a negative x, does it go back to the original? And then odd is whatever's happening in the top right flips to bottom left or top left to bottom right. Or if I plug in a negative, does my sign change? If all my signs change, then yes. Yeah. Okay, now we go to horizontal shifts. So a horizontal shift happens inside the function. I'm going to add on again the cube root. And this time the reciprocal would look like this. It would be in the denominator. Oh, my f of x went away on the other one. What's weird about the horizontal is it goes the opposite direction your brain thinks. So when we add, we are not shifting to the right, we actually shift it to the left. And when we subtract, we shift it to the right. If you forget and you're not sure, you're questioning it, you could always set this function equal to 0 and find where it crosses the x-axis. If I set it equal to 0, and let's say I square root it, whatever, when I subtract the term inside the variable, inside the parentheses, that's when it moves it the other direction. So if I'm unsure, you could always find the x-intercept. You could set it equal to 0 and find it from there. All right, and those would look like these. So again, our parent function is f of x equals x squared, and it looks like a parabola. What's happening with A? Moves to the right 2 places. So I'm going to go to the right 2 places, up 1, out 1, and draw the parabola. My domain is still all real numbers. My range is 0 to positive infinity. It's decreasing from negative infinity to 2, increasing from 2 to positive infinity, and this time it is not even because it is shifted off of my axis.
So it would be neither.
It would be neither in this case. Yep. How about B? Describe your transformations. It'd be left 2 and down 3. So I'm going to go left 2, down 3, or down 3, left 2. It doesn't matter what order you do that in. And then go up 1 and out 1 and draw your parabola. Still good? All right, then you've got your reflection. There are two types of reflection. The first is across the x-axis. If the negative is on the front of your function, it would be negative cube root of x, or it would be negative 1 over x if it was reciprocal. If the negative is on the front, then it flips it across the x-axis, or shifts it upside, or flips it upside down. If we're looking at it, it's going to flip it upside down. So it's going to take your parabola and point it down. It's going to take your v and point it down. It's going to take your cubic function, so it normally goes like this. It's going to flip it upside down, so it looks like this. It's going to take your square root and point it down. That's if the negative is on the front of your function. If the negative is inside the parentheses, so if it was like a negative x squared or a negative x to the third, or a cube root of negative x, or 1 over negative x, I think I got them all, oh, the absolute value, or the absolute value of negative x, if it's inside, then it flips it across the y-axis, which flips it left to right. Now, for some of these, it will look exactly the same. Like if I took an absolute value, or I took a parabola that was on the axis and I flip it left to right, it looks exactly the same. Same would happen for your v, okay? It would look exactly the same. What would change is if it had a shift initially. So if I shifted to the right, a parabola, and then I put a negative inside, now it's going to shift it to the left. So if the negative happens inside, let's say it looks like this, then I can approach it two ways. First, I can do the horizontal shift. So what would be the horizontal shift initially? To the left 3, so I can move it to the left 3. And then I can take the negative x that says flip it over the y-axis, and now it shifts it to the right 3. Or if there's a negative on the variable inside the function, so inside the parentheses, inside the absolute value, underneath the square root, with a horizontal shift, then it changes the direction of your horizontal shift. So this changes that to go right. So you can also just do that. You can either plot it and then flip it, or remember that if a negative happens inside your function and there is a horizontal shift, it changes the direction of your horizontal shift. Now what does look completely different is the square root with a negative underneath, because this one, instead of pointing this direction, it points left. And a cube root, instead of pointing like this, it flips the other way. And, well, a cube root looks exactly like an x cubed looks exactly like if it's negative underneath. So if I flip this over the x and y, it flips it this way. Doesn't matter if you flip it with the negative on the front or the negative inside the parentheses, it does the same thing. And then your reciprocal function initially looks like this. And if I flip it over the x or over the y, it puts it here. So for some of them, the reflection over the x-axis looks the same as the y-axis. You just got to think about what you're doing. On an AP style question though, it will ask you to describe the transformation and it's specific to the axis. So if there's a negative on an x squared and it's inside, that would be over the y-axis, whereas if there's a negative on the squared and it's on the outside, it's over the x-axis. So you have to be specific to where the reflection is happening to. All right, so let's talk about these. Again, what would the parent function be? Square root of x. So if it asks for the parent function, we're giving the equation. What does it look like? That little arc pointing to the right, right? So if I go to A, what's the transformations? Describe them. What's the negative on the front do? Reflection over x-axis. It flips it upside down is what it looks like. But when you're describing it, you have to say it that way. Reflection over the x-axis. What's the plus one inside doing? It's a translation to the left one. So I'm going to take my square root. I'm going to shift it to the left one. And I'm going to flip it upside down. I do not need these to be perfect. If you want to plot some points so that you understand where you're going, fine. Like to confirm your shift or whatever. But for an estimation of your graph, it does not need to be perfect. All right, now go to B. The negative underneath the square root does what? Reflection over y-axis, which means it's going to point left. And the plus 3? It's outside, so it's good. It's up 3. So I'm going to go up 3, and I'm going to point it to the left. Now, square roots will always have a restriction on domain and range, right? So if I go to A, my domain is from -1 to positive infinity, because my x values start at -1, include -1, go to positive infinity. My range starts at negative infinity and goes up to 0. So when it points down, my arrow's at the bottom, which means it's coming up from negative infinity. It would be decreasing that whole time, so it'd be decreasing from -1 to positive infinity. It's technically just over 1 and up 1 unless there's a vertical stretch. Oh, like how did I start here?
How did you continue?
Yeah, it's really up 1 and left 1. If you want to plot a point, you can, but really as long as you draw that arc going in that direction, it doesn't have to be perfect. And then on B, your domain is negative infinity to 0 because my arrow points left. And my range is 3 to positive infinity because those y's are pointing, it's pointing left, but those y's are getting bigger. And this time it would be decreasing from negative infinity to 0. All right, so here's where the language changes a bit from Algebra 2. When we describe these non-grid transformations, they are called dilations. So everything up to this point is called a translation. Okay, up, down, right, left, or reflected, we refer to as a translation because we are physically just shifting our graph around. A dilation is a change of the shape. It is a stretch or a shrink. In AP language, we call it a horizontal or vertical compression or stretch. And sometimes they will use the word compression and stretch, and sometimes it will just say a dilation. So we'll talk about the difference when we get into an example. The first kind is a vertical. So we used to call this a vertical stretch or for a vertical shrink, okay? If you could think about your initial function and then like tying a string to the arrows and pulling it from top to bottom, like you're stretching it vertically, or squishing it from top to bottom, like the ceiling and the floor is caving in on it, that is a vertical dilation. And it occurs when you have something multiplied on the front of your function. So if I had 2x squared, or I had 3 absolute value x, or I had 4 square root x, those are all vertical stretches. If the number that's there is bigger than 1, and we ignore the sign, so notice it says absolute value, because a negative does not impact my dilation. The negative on the front does what? It flips it. It's a reflection. So those are two separate parts. The negative is one thing. The number is the other. If the number is bigger than 1, then it stretches it by that factor. So if I said, what's the factor of the stretch here? I would say that is a vertical dilation by a factor of 2. Or a vertical stretch by a factor of 2. If I'm given coordinate points, then I have to think of what impact it has on coordinate points, because eventually when we come back to these in the AP content, you're literally going to get a chart of points, and you're going to have to alter the points. Or you're going to get domain and range, and you're going to have to alter domain and range. So let's think about what's happening. If it's a vertical stretch, which coordinate gets affected, the x or the y? The y, right? Vertical would be the y. If it's a vertical stretch by a factor of 2, then I would take my y and double it. That's what a vertical stretch by a factor of 2 does, okay? In this case, it says if the coordinate point started as 2, 4, and then the factor is 4, then I would say it is, or the factor is whatever c is, then I would multiply c by that 4 to alter it. So this means if I started with, let's say I start with an absolute value, and I had a point that was 1, 1. This is my parent function. That coordinate point is 1, 1. And now, so the purple we would have said is just absolute value of x. Now I want to do absolute value of 3, or 3 times the absolute value of x. This is a vertical stretch by a factor of 3. And if I want to graph that, that means I'm keeping my initial point the same. 0, 0 would have no change. But my 1, 1, I would multiply the y by 3, which means it's now 1, 3. So whatever the vertical stretch is, I would alter the y coordinate by multiplying it by it. If the value on the front of your function is between 0 and 1, or the absolute value of it, again, we're ignoring the sign, then it's called a vertical compression. It's as though the ceiling and the floor are squishing your function from top to bottom. It flattens it out or makes it wider. And it would be the same by a factor of whatever it is. So if this said 1/2 square root of x, then I would say it's a vertical compression by a factor of 1/2. And if I was to graph them both on the same initial coordinate grid, then my parent function would be at 0, 0 and 1, 1, because it would be just square root x. And this vertically compressed by a factor of 1/2 means that 0, 0 is still the same, but my 1 is going to get multiplied by 1/2, so it goes to 1/2, and it would look like that. So it's been compressed by a factor of 1/2, or dilated by a factor of 1/2. So if I had coordinate points, and it started as 2, 4, and then whatever my value of c is, I would just multiply it by the 4. For a vertical compression, we're changing the y. You with me so far? Because this is the part that most people struggle with, is the difference between the vertical and the horizontal compression. Okay. What the difference looks like with a cubic function or a polynomial, okay? If I took the graph on the left-hand side and I say that the original graph is my solid line, and then I look at this dashed line, what kind of dilation happened there? Was it stretched vertically or was it horizontally compressed? Horizontally compressed. So this one has a clear difference. Does that make sense? Some of them don't look very different. The absolute values and the squares are not going to look that different. But this one definitely has a difference. My y's did not change at all, right? The y here didn't get taller. If it got taller, that would have been a vertical stretch. But it shifted in. So that got squished from the left to the right, and this would have been a horizontal compression. So if I had multiple choice question here and it said which of the following could be the equation of this, and my original equation just said f of x equals, I don't know, x to the third, it wouldn't have said that, but let's just say it said that, then my choices, one might be f of x equals 1/2 x to the third, and b might be f of x equals 1/2 x to the third, and c might be f of x equals 2x to the third, and d might be f of x equals 2x to the third. And you would have to differentiate which one is which. So what causes a horizontal compression? The number has to be where? Inside. And if it is shrinking from the sides, what's happening to my x values? They got compressed. They got smaller technically, but with my horizontal compression, I flip it, which means the answer here is C, because that's the one that's going to cause a horizontal compression by the reciprocal of that, which is 1/2. Does that make sense? That is an AP style question. That is what you will see. You could get some that literally just says describe the transformations, and then you get suckers like that, in which you will see a graph and you have to figure out which one it could be. Okay, now go to the second one. This time the red is the original. So the red is the parent function, and the blue is the translated or dilated graph. What kind of dilation happened here? A vertical stretch, okay? So a vertical stretch in which I look at this y was at 2, this y is at 6. So it's a vertical stretch by what? Factor of, I went from 2 to 6. A stretch means multiplication, right? So we took the 2 and we multiplied it times 3. So a vertical stretch by a factor of 3. And that would be a 3x to the third, like that. So the vertical we don't mess with. The horizontal, we do the reciprocal. Questions? Again, that's when it gets messy. Okay, if you're like even half asleep, slap yourself, wake up, because horizontal is where it gets weird, okay? So a horizontal dilation happens when you are multiplying by something inside the function. So it happens inside the parentheses, or inside the absolute value, or underneath the square root, or in the denominator, something like that. And for these, the actual visual change is almost the same as vertical, but the wording is opposite. So if the value is bigger than 1, and again, we ignore the negative. If the value is bigger than 1, then it's a horizontal compression, okay? So now picture you have a parabola. And what would happen if I compressed it horizontally? I'm squeezing the walls in. What's going to happen to those branches? They get more narrow, which is almost the same as they're vertically stretched, right? There is a difference, and you'll see it in a little bit. But it's almost the same thing as it being vertically stretched, okay? So a vertical stretch visually, a lot of the times, looks very similar to a horizontal compression. And those are both caused by a number bigger than 1 being multiplied. The difference is it on the front or is it inside? And then how we find the factor of the horizontal compression is also different. If the number inside was something like, let's say it said parentheses x 2x squared, now the number's inside, then the factor of the compression is the reciprocal of what's there. So this would have a horizontal compression by a factor of a half. So vertical we leave alone, horizontal we make its reciprocal or divide, 1 by it, same thing. Now think about how that would affect it, right? So if my x values are what are being impacted now because it's horizontal, then I can choose to do two things. One, on this slide it says it, take your point, so 2, 4, and then divide the x value by the value that's in your original equation, by the c. Or you can take your x coordinate and multiply it by the factor, because the factor would already be divided by c. So I don't care how you do that. I think it's less confusing to do the factor, because you already find the factor. All you have to do is multiply it. And then the opposite occurs if it's in between 0 and 1. If it's in between 0 and 1, then there's a horizontal stretch by a factor of 1 over c. So this would be like a half x squared. Inside the parentheses is in between 0 and 1. So it causes a horizontal stretch by a factor of 1 over c, or the reciprocal of the value that's there, which means that it's a factor of 2. Good. And if you think about it, what happens if I double the x value? It's pulling the sides away, which is also the same thing as a horizontal stretch. All right. We don't have to go into minute detail on this, but if I look at A, well, first of all, what's my parent function? F of x equals absolute value of x. What's the shape of it? A V. If the 3's on the front, what's happening? Vertical, stretch, factor of? Good. So my normal absolute value starts at 0, 0, which is going to stay that way, and then goes up 1 and to the right 1. If it's a factor of 3, instead of going up 1, right 1, it's going up 3, right 1. And B, what's the dilation? It's inside, so what? Vertical or horizontal? Horizontal. And if it's horizontal, what do we do to that? We flip it. Yeah? So if it's 1/2, that means it's a horizontal stretch factor of 2. So my 0, 0 stays, but my 1, 1s, I change the x values. I multiply the x value by 2. So it goes 2, 1. Let's do some practice. Now we put it all together. So this says identify the parent function, describe the sequence of transformations from f to g, sketch the graph of g by hand, and then use function notation to write g in terms of the parent function f. So I'm going to walk us through that process first. Well, before we get to it, not first. First, we're going to identify the parent function. What's the parent function? X squared. So f of x equals x squared is my parent function. It's going to look like a parabola. Describe the sequence of transformations from f to g. So I'm going to actually just go straight to the equation, and I'm going to point to all the parts. So this 3 at the front is causing what? Vertical. It's there to throw you off at the front. It can go at the beginning or it can go at the end. It doesn't matter. If it's separated by a plus or minus, right? It's a vertical. So this is up 3. The 2 on the front of the function is causing what? What kind of dilation? Vertical or horizontal? Vertical. Stretch. factor of 2. And the minus 4 inside the parentheses is causing? Good. A shift right 4. Typically, you don't have to say a vertical shift up 3 or a horizontal shift right. If you say up, I know it's vertical. If you say right, I know it's horizontal. Okay. Now, I'm going to lightly just give you the parent function, which is 0, 0, 1, 1. It would have looked like this. You don't have to do this because at the end, I just want to see the one that's moved. And you're going to take your 0, 0, okay? You're going to plot this. I would plot these points, okay? And then the rule is if you stretch first and then move, okay? So if you think about it, like I said, like when you wake up in the morning before you get out of bed, sometimes you just want to stretch before you get out of bed. So you're always going to stretch before you move. So I'm going to take these points and I'm going to shift them or adjust them by multiplying the vertical, which is the y, by 2. So instead of going out 1 and up 1, I'm going to go out 1 and up 2. So now my graph is like this. It's a little bit more narrow. Then I'm going to, the right and left and up and down order doesn't matter. I'm going to shift it to the right 4 and up 3. So I'm going right 4 and up 3. And then my up 1, up 2, or right 1 and up 2 is the narrowness or the vertical stretch. Now D says use function notation to write G in terms of the parent function F. And this is what AP style questions love. Because it wants you to not even know what the shape looks like, but to actually take the equation and transform it. So if I remove the parent function, which is the x squared, every time I'm going to use x squared, I put an f in its place. So x squared is f of x. So I'm going to take f of x. So let's just say I start with my regular f of x, if it looks like this. And I'm going to make all those transformations happen to f of x. So if I wanted to move f of x up 3, what would I do to this equation? Add 3 to it. Doesn't matter if I add it after or before, because as long as it's not inside the parentheses, it causes a vertical shift up 3. I want it to be stretched by a factor of 2. How would I take f of x and stretch it by a factor of 2? Multiply 2. So the 2 is going on the front of the f of x. And I want it to shift right 4 places. How do I do that? Inside the parentheses, I'm going to subtract 4. So g of x is my shifted function, is going to look like 2 f of x minus 4 plus 3. And that is the way you will get a lot of your AP style questions. Because you don't know anything about what that function looks like, it will just ask you to describe what happened to your original transformation. Does that make sense? Yeah? Okay, let's do it one more time. Identify your parent function. So what is f of x? Absolute value of x. It looks like a v. Let's describe the sequence of transformations from f to g. So the minus on the front, what happened? Reflection, specifically, over x-axis. Flips it upside down. The 2 inside. Horizontal.
Compression.
Good. Compression. Factor of? Good. And the minus 4 inside the parentheses, right 4. Now it typically will give you that notation where the variables, like where it's actually outside of the expression of x minus 4. If it had said 2x minus 8 like that, I would have had to factor out the 2 to separate the compression from the horizontal stretch, but it will typically give it to you the way that it's written there. Okay, so my typical graph is up 1 and out 1. It would have been like that. but we're gonna compress the x coordinates by a half. So we're still gonna go up 1, but instead of going out 1, we're only going out a half. So we're going out a half and up 1 and out a half and up 1. And so it would have been something like this. So now we're gonna go to the right 4. We're gonna shift it over 4. And we're gonna do the same thing. Go to the right a half and up 1, right a half and up 1. Oh, but we're gonna go down. So down and out to flip it over the x-axis. Now C or D says use function notation to write g in terms of the parent function. So I want to alter my f of x in such a way that it would be reflected over the x-axis, which means put a minus in front, that it's horizontally compressed by a factor of a half, which means add a 2 to the front of the x, and that it's shifted to the right, which means subtract 4 from the x. So it would look like g of x equals negative f 2 parentheses x minus 4. If I distribute that 2, it would still be right, but you don't need to do that, so it's easier to keep it here. Just be careful and make sure you keep those parentheses so that we know the 2 only impacts the x. If it had impacted that 4, it would change it to an 8.